I think I'd actually like to start with trying to get a distribution in the room so I know who I have to fight here. How many data scientists do we have in the room? Okay, most. Okay, we're winning here, Data engineers? Machine learning engineers? Okay, there's a few lone soldiers, and someone who has to do the terrible job of DevOps, model ops. Okay, this one's for you. Has anyone here, I think the last question that I'd like to know is, has anyone heard about Kedro before this talk? Some people. Okay, that's pretty cool. Brief introduction about me. I am a product manager at Quantum Black. I'll be explaining a bit more about what the company does in a moment because it explains why Kedro exists. The only thing that I managed to do, no, I'm kidding, beyond being part of an amazing team at Quantum Black is open sourcing it. Open sourcing something from a consultancy is a nightmare, guys. But it had to happen, and I'll explain a bit more at the end of the presentation about what that meant. I have a background in data engineering and data product management, so I could have actually been a user of Kedro as opposed to being the builder of it. At least I come with it with that level of empathy, and I always joke that I'm 65% South African. You can ask me at the after party what that means. I should actually explain a bit more about Quantum Black and why we actually think about Kedro. So Quantum Black was an advanced analytics company that was acquired by McKinsey about 4 years ago. They say we were born out of Formula One, where our co-founders used to do kind of high-performance race car analytics, and eventually went on to saying, hey, how about we apply these principles to businesses? So we're kind of like the black ops in the firm, in McKinsey, and our job is basically to make sure that we put code into production and we deliver business value when we do that. I sit within Quantum Black Labs, which is technically our product engineering, where we basically help build tools that help our teams do that. So this introduces the Kedro story, but I'm going to start off with a few definitions so that we're all on the same page. So when I talk about a data pipeline, I'm talking about the process of taking data from somewhere, doing something to it, and putting it somewhere else. So something to it could be a machine learning pipeline. It could just be an extract, an ETL process as well. I also will refer to that. When I talk about production-ready code, I'm saying that your code is going to be reproducible because many people are going to try run it or work with it with you. We also talk about it being modular, so that it's broken down into small composable units, and then it's also well documented so that other people can understand it. And then the roles within Quantum Black, which I'll keep referring to, in our world, I don't know, because these roles are very new and upcoming. In our world, the data engineer is the person who works in any data environment and then basically helps construct the master table. So you'd go through your different, we have what we call our data engineering convention, where you move from the raw layer all the way to primary to the model input table, and that is that person that does that. Our data scientists are basically PhD, masters, people that focus on actually applying modeling techniques to the master table. And then our machine learning engineers in our world, in our definition, is the person who basically says, okay, we've got a data science model, we now need to put it back into whatever client infrastructure exists. So, why does Kedro actually exist? We have larger teams when we actually go out on our client engagement. So you're typically working upwards of 4 people on the same code base, sometimes up to 10 people on the same code base. And what typically happens is if it's just me working on my own project, yeah, I know how I usually do things on my project. But if there are 10 people that think that, it makes it really challenging to collaborate with each other when you do that. Clean code is also expected from us because our measure of success is not necessarily just handing over a code base and running away. Our measure of success is actually being able to work with companies that can maintain their data pipeline when we go. That is success for us. So it's this whole thing of the code is clean because you need to understand it, because a data pipeline is not static when it's delivered, it's still fluid, and you might need to modify it in future. So we have high standards for that. We also don't have time to refactor bad code, badly structured code. There's time to do, obviously, code optimization when you put the model into production, but thinking through that whole process of restructuring bad code, we don't have time for that. And then also we come at it with this level of empathy. So everyone keeps saying, I think Mariana in the previous session mentioned the data scientists should learn kind of these software engineering principles. But we approach it with that empathy of, you have a workflow, you have a certain level of expertise, let's bring everyone to a higher bar together. And that's actually why Kedro exists. So if you pip install Kedro, if you want to try it now, you'll actually have access to the tool. We managed to open source it in June earlier on this year. And I'm going to let some of the Kedro users in the next video introduce what it does. And if sound works, we'll be happy. Or no. Let's see. Should I try again? Yes. Yes.
Hi, I'm Philip, and 6 months ago, this was me. Code was my life. But mine wasn't really production level. I was often misunderstood.
Philip's approach was unstructured, making it challenging to collaborate.
So that's where Kedro came in.
Hi, Philip.
Hey, Yetunde.
Going down. So, for us, the only really useful data science code is production level code. And the really exciting thing about Kedro is...
It helps you structure your data pipeline using software engineering principles.
Meaning your code is production ready from the get-go.
So you can spend more time focusing on building your data pipelines. Kedro also standardizes the way your team collaborates,
making it easier to transition from development to production.
Breaks large chunks of code into small, modular units.
That can be easily tested, which means that...
Sorry guys. Which means it's easy to identify and rectify errors in your data pipeline. Hey, am I an analogy?
The Kedro project template is really easy to use. It looks great and it standardizes everything, which means
collaborators aren't wasting any time figuring out how I've set up my analytics project.
So for him, it's all about data abstraction.
Yeah, sure it is. I like how Kedro helps me manage saving and loading of data, so I don't have to worry about the reproducibility of my code in different environments. Sometimes this means even in here.
And the configuration management keeps credentials out of my code base.
The development is test-driven, the code quality is monitored. I know my data pipeline is robust and production-ready.
And packaging allows us to easily produce well-documented code and ship it to Docker. Plus, it's open source, which is a first for Quantum Black and McKinsey. If you take away anything from this video, then it's this.
Kedro makes it easy to deploy machine learning models in production because it applies software engineering principles to data science and data engineering code.
And that anyone can understand.
Cool. So that was actually made when we were open sourcing. Those are all people that exist within Quantum Black. It took me 10 tries to try and film my bits for it. And I almost wore the same jersey today. I'm glad I didn't. So Kedro, we open source it. It's maintained by the Quantum Black teams. And we kind of think of it as the bridge between machine learning and software engineering. It helps you build data pipelines that are consistent, they're versioned, they're reproducible, and they're scalable. The 5 concepts I'm going to focus on today are going to be how we think about a project template. Who here is actually familiar with cookie cutter data science? You guys are good, so you'll quickly pick this one up and understand it. We're going to talk about how we think about configuration, how we manage our data catalog as well. You can think of it as basically a series of data connectors that can connect to any type of data source that you need for your machine learning workflow. We're going to talk about our nodes, which are our way of referring to our tasks, so-called tasks in pipeline framework terminology. And then we're going to talk about how we construct our pipeline as well. I will take you through an example, so you'll see all these components come together. So project template, and this basically falls in line with the whole thing of the cookie cutter data science. It's this whole way of having basically a standard way that everyone interacts with an analytics project. It means that you're not spending time sitting down with someone and explaining to them where you've located all your code and like where things should sit, because everyone knows that this is the way that the project is structured. So our project template also supports Sphinx for documentation. So if you're using Google Doc strings in your functions, Sphinx docs will pick that up, so your code is like documented for you. We do support PyTest as well in the template, as well as standard like Python logging as well. So those elements of like good practice that you should have for your data pipelines are basically embedded in it. It's also modifiable. So since we've released Kedro, we've actually found interesting ways that people have been modifying this template themselves. So obviously they don't like our opinion in some ways, and they're actually modifying the template to do even more things than they want. We generally think of it as like the best starting place for you, because it's basically built with, I think now, over 90 major client engagement best practice like built into this template. I'm going to specifically dial into configuration though. And we think of configuration as your way to move from prototype to production with ease. It's this whole belief that the same code that you write, because it doesn't have any hard-coded variables in it, can easily be translated when you move it. So we support configuration for logging. So you might have different ways of logging for development versus in production. We also support it for what we call our data catalog, which I'll be taking you through next. So no hard-coded file paths will be located in your code base. And then also for parameters as well. The parameters one is really useful because for the first time, you basically, or I think if anyone is ever going to come and look at your work, they know that all your parameters are located in like one place. So it's easy to refer. They don't have to basically like dig through your code base to try and find like which functions match which parameters. We talk about a data catalog, which is our data abstraction. It's completely extensible and available via a code API or a YAML API. It basically is our series of data connectors, and we support, obviously you see like many different formats currently. And the list is actually currently growing because we're finding different ways that people are actually, or different requirements that people have for being able to connect to different data sources. Currently supported storage layers include S3, also AWS S3, and then Azure Blob Storage on some of the data sets as well. But our abstract dataset class is really easy to extend. When you come down to it, I think it's about like 15 lines of code that you basically just need to extend for whatever data class that you have that we don't necessarily support in Kedro. And then when you're using the built-in functions as well for referencing pandas tables and Spark tables, they use the same load and save arguments, so you're not learning a new API when you use them. We also do support data versioning every single time your data set is saved. And in the latest version of Kedro, which was released yesterday, we're actually starting to tie the data versioning to your code. So we'll be able to one day automatically reproduce Kedro runs or pipeline runs. The next concept that I'm going to be addressing is obviously how we think about our tasks. In Kedro land, tasks are Python functions or PySpark functions, depending on what you write. That's it. When we say we're referring to a node, it's basically this whole component over here where we've got an input of some sort, we've got a Python function that requires this input, and then we've got an output that comes from it. When we think of our pipeline, it's basically stitching together those different nodes to construct it, and you'll actually see it in the code syntax how easy this is. Because you do that, you basically get what we call Kedro Viz, another Kedro plugin out of the box based on your code. A lovely way of being able to communicate to your business stakeholders why your machine learning model is not ready on week one, because you have a lot of data cleaning and feature engineering to actually complete. That's actually how our teams use it, to basically say, hey, we're doing so much work before we can even look at the data science part of our workflow. And here's actually how we get through it. Kedro Viz is also open sourced. In terms of being able to package Kedro, we do also support, obviously, Kedro Docker, which is your way of being able to package your Kedro project in a Docker container. Interesting ways that our teams have been able to scale with it is obviously Kedro Docker, and Kubernetes as a way of like orchestrating those different containers. And then if you really need to transition to something like Airflow, we also do provide that flexibility for you to do that. The reason why you choose to start in Kedro is because it's much easier to get started in Kedro than it is in Airflow. So in terms of being able to, I guess, bring everyone up to a level where they can eventually move their code to Airflow, Kedro definitely helps with that. So the example I'm going to actually give you today actually takes you into the year 2160. For whatever reason, we do not have algorithms that write algorithms, and your job is to produce a price prediction problem to understand how much does it cost to fly, what factors influence like flying to the moon and back, because there are thousands of space shuttle companies out there. So you can tell we had a lot of fun writing this tutorial. It's actually in our docs. And we also do support the full code base in Kedro examples as well. So I'm going to use a modification of this. I'm not going to focus on the price prediction component of it. I'll just focus on the pre-processing pipeline that produces the master table as a way of like really simplifying it so you can see how all of these Kedro concepts fit together. The first thing I'm going to do, though, is actually show you Kedro Viz, so you actually understand how this is a very basic pipeline. We had 3 input tables. A companies table, which basically had all the company information. We had the shuttles information, so each company has multiple shuttles, also as an input there. And then we also have customer reviews from that information. So you can see over here, shuttles, companies, reviews. The shuttles table had to undergo some pre-processing, and so did the companies table. We had the output tables coming out as pre-processed shuttles, pre-processed companies, and then together with reviews, they were fed into the master table. So the first thing you're going to run is Kedro new. So you pip installed Kedro, hopefully in some sort of like virtual environment, because we also believe in good practice for Python package dependency management. So Kedro new basically generates your project template. Like I said, this thing is completely extensible based on like whatever you need on your project. So if you find you don't need all of those files and folders, delete them. Like you're ready to go. The next thing you're going to do is now set up your data catalog. So for this very, very basic example, we have access to 2 CSV datasets and 1 Excel dataset as well. When we're using the YAML API for the data catalog, you can actually see how we indicate the different datasets. This is basically becoming our data registry where we can say, here is the type of dataset. Here are many different parameters or maybe arguments that I need to actually load that data, and sometimes even save the data as well, and where it's located. If you do use Jupyter Notebooks, we encourage using them for exploratory analysis only. So this whole thing of being able to still support, I think, what they're good at, which is helping you explore the data and I think produce your initial version of your pipeline. Our data scientists do work like that, but they move out of Jupyter Notebook into Python script so that they can obviously construct their data pipeline. So in this case, your workflow with Kedro looks at reloading Kedro to reload essentially our Kedro context. And then you basically can access those data sets with context.catalog.load, which in 15.2 is now just catalog.load. And you basically have access to all of those data sets called from configuration. So this whole thing of your workflow with Kedro does not have file paths in it. Does not have large chunks of code which basically load those data sets for you, because that's specified in configuration for you. When we talk about, obviously, a Kedro node, we're talking about a Python function. So here is an example of a Python function used to actually pre-process the shuttles table. You'll note, additionally, we do have doc strings in there. So this is the whole thing of being able to produce well-documented code. So if you just indicate that in your Python script, you're ready to go. When we construct a Kedro pipeline, this is actually what our syntax looks like for that pipeline. I'm going to break it down for you. So here's actually how we define our pipeline. Here is a node for pre-processing the shuttles table. So you note, pre-processed shuttles was the actual Python function. The input table was that shuttles table that we defined in our data catalog, and the output table was pre-processed shuttles. I'll be talking about preprocess shuttles, preprocess companies in the second example, and the master table in the last one. So over here, we've got preprocess companies as the next Python function that we made. It's input table companies. It's output table preprocess companies. The node syntax also supports multiple inputs and multiple outputs as well. And in this case, we need the multiple inputs to join the three tables together. So create master table was the Python function that joined everything together, and the output of it was the master table. Those output tables were not actually defined in our data catalog. And what that means to Kedro is that those objects, those data sets, are passed in memory until they're needed. If I actually needed to save them, I'd actually have to list them as entries in the data catalog and tell Kedro where they should be saved. Really useful for debugging if you do work like this, but otherwise, I think when you move later on in your development process, when you're sure of your data pipeline, it's just easier to just remove them for the data catalog and use the memory data set to actually do that. And all you need to do is just delete them, and they disappear. We then execute Kedro run, and you will see that we use obviously Python logging. Everything is saved in your logs folder so that you have access to it later. So this is the run of a successful execution. We do have access to then Kedro Viz, once again, where you visualize your pipeline. And then there are many different ways of being able to package your work. You can build docs. You can build the requirements that you need for your workflow, so you can hand over effectively. You can actually package your Kedro project or Kedro pipeline rather, as an egg or wheel for deployment. You can do Kedro Docker build, which will build the Docker image of your Kedro workflow. And then also you can Kedro Airflow create to create the Airflow DAG that you'd need in your Airflow workflow. So overall, our status to date is that we're used more on 90 advanced analytics projects within the firm. So that's each company, many different industries, is using Kedro. We open sourced in June 2019, primarily because our clients wanted to be able to use it after we left. So they'd have a great time when they're using it with their data scientists, and we're using it with the data scientists. And then when we left, they'd be like, wait, but upgrades? Support? And we're like, whoa, open source. And we fixed that issue. That's basically where we see, like, obviously building a community becomes, like, really important, but that's a component. We're watching it grow organically, but that's something that is happening now. And then we're also looking into some of the stuff on performance scaling for Kedro, so making it easier to, when the Kedro pipeline is in production, to basically get performance benefits from it. So I don't know if you guys are familiar with an open source project called Dask. We will be looking into Dask integration. And there'll be a new way to deploy Kedro pipelines with the Kedro API. If you do want to access like resources for Kedro, Kedro Read the Docs, we spent a ton of time on our documentation. There are 2 tutorials in there, a Hello World Iris dataset example that you can have access to, and then also the longer form space slides tutorial that I was just taking you through. We're up on GitHub as well, so that means Quantum Black Labs /Kedro. You'll find us there. As mentioned, the project is maintained by us, so you will see me like lurking around responding to like your issues and your pull requests. We have something called a wizard every week. So it's a team of 8 that maintain Kedro, and our wizard is basically like staffed to basically handle like all concerns that you have. And then if you do post questions in Stack Overflow and tag them with Kedro, not that anyone has yet, we will be able to find them. I think one of the reasons why we are watching Stack Overflow is because we still speak on our internal Slack about Kedro, and I'm trying to get our guys to move outwards so that this information is shared across and we don't have information loss. And that leaves us down to questions.
Thank you very much. Lots of questions. All right, let's see.
Hi, thank you for your talk. Just a very quick question. You were mentioning that Google Cloud integration will be available soon. Can you give any update on how that will happen?
Sure. So we actually do have a pull request, at least for the CSV dataset, on Google Cloud Platform. Okay, there's 2 ways to look at it. if you need to use Kedro as of this moment, all of our S3 datasets can basically support GCP. You just need to change one parameter, and then you're only using like the read and write binaries from Google Cloud Platform. That's like if you need to use it, like you're burning, like need to use it now. But as for being able to move the pull requests through, we did have an external contributor raise the CSV GCP dataset. And it's on the backlog, I think, for the next 2 sprints to actually complete the catalog of GCP datasets. So maybe another 2 weeks, we'll have like the full suite, including Google BigQuery as well.
So in the example that you showed of the structure of the project, I assume this is so committed into source version control, and I see the CSVs here in a folder. So I understand it's an example. How does it work with larger data sets that are maybe in cloud storage? And I'm just curious how it would work with some real data.
Mm-hmm. Definitely. So that data folder in the project template is actually get ignored. So this whole thing of not committing data is good practice. Don't do it. Don't do it. How does it actually work? So the data, remember, if we have a look at the data catalog and the way that it's actually structured, just going to go back. Might be easier to just click here. This guy. You can connect to any data source wherever it's located, so it doesn't necessarily need to actually sit relative to the project for you to be able to use it. Wherever you specify the file path, like basically Kedro will read it from there. That's why we consider the data catalog as like a connector to it. But yeah, in terms of like committing or using data relative to your folder structure, that doesn't work. So that's actually why we can support like big data pipelines as well. Within Kedro, because it doesn't usually look like this. This is like a very basic example. So you can connect to different cloud storage layers, and some teams are now building connectors for Delta Lake. They just need to now write tests for it so that we can actually put it back into our contrib layer. And that's why they've also been hacking around with like GCP. So you can just connect wherever wherever your data is located.
Hi, thank you very much. One question about the possibilities for data lineage. So this is something that many people want to do, like in many pieces of software, and it's a big problem. So what can Kedro do for discovering data lineage from an end data set to all the intermediate states?
Good question. So in terms of data lineage, like there's 2 ways to look at it. Kedro Viz already supports an ability for you to just see the data workflow. So you would have seen it from where the sources of data were coming from to what was the final output in the end, or the final model that you had at the end. So you can already see that layer in Kedro Viz. And obviously our data engineers will work according to a structure convention, which you can read about in our docs, like how they structure that workflow. So it's all there. But we want to actually take it a step further. So there's always been talk about how we even enable column level lineage in our data sets. We haven't quite cracked that model yet, but at least for now, you have a vision of where the data sets land up.
Hi, yeah, thanks for the talk. So you were saying you look into Dask integration. So currently, Kedro then brings its own scheduler. Does it also support parallel execution?
Good question. So Kedro does not support its own scheduler currently, so we rely obviously on tools like Airflow or whatever you want to use to do that. We do have parallel execution though, so you do have choice within Kedro for a sequential runner or a parallel runner. What we will do, what our Dask integration prototype actually looks like is creating a Dask runner and then subsequent like Dask datasets for you to be able to take everything into Dask and run it accordingly like that. So that's actually how that workflow would look.
More questions?
Thanks for showing us these convenient features in Kedro. I have one question relating to the video that you've shown. Basically, let's pretend I'm a data scientist who tends to write graphic code. How does Kedro prevent me from doing that? Can you maybe give some examples?
Rabbit code, lasagna code, spaghetti code. So for this one, how would it prevent you? So I think the first thing is we do abstract a lot of like the software engineering concepts as well, so that you don't necessarily need to think about how I'm going to implement these things on your own. The only way I would recommend this is, following actually the basic tutorial. Will actually take you through that complete workflow of I set up my project template, I have to connect my data sources wherever they're located. I have a Jupyter Notebook workflow, which is what I was previously using before, but we show you how to just tweak it a little bit so that you're already getting better code. We even have a way to export your code from your Jupyter Notebooks. It's Kedro Jupyter Convert, to actually export your code into essentially the Python script. But this is done on the caveat that you still at least have knowledge of, I need to be writing Python functions, so modular code as well, because otherwise then Kedro doesn't really fit for your workflow.
Thank you for your talk. I missed something about versioning the models. Is that available?
It's available, kind of. So the reason why we do support model versioning now is because we look at models as data sets. So dataset versioning essentially means in Kedro, every single time my pipeline is run, I will be able to save a version of it with a timestamp that is linked to it. We obviously don't do what we call then experiment tracking, which is where we look at, okay, how do we look at how this model is like evolved over time and actually be able to have a way of comparing it. We rely on another internal tool. It's called Performance AI. There's a Medium blog about it where they have basically built on top of MLflow to make that functionality like fleshed out for our users. But where we will be taking the model versioning to is, I think it's probably going to be in release like 15.3 or 16, where we actually have now tied what we've called our data versioning to code. So that it's not as useless as it currently is with how we think of that.
About catalogs, it's very similar to the intake project. Have you compared the two, and what are the pros and cons?
So intake, I think intake is you could think of it as our feature competitor on data abstraction. It's a project by Anaconda that you guys should check out because it's also a really cool thing. They have a GUI as well for helping you load data sets, but they obviously do use the YAML API layer as well. We do both loading and saving of data, which intake does not do. So that would be I think the primary differentiating factor. So our catalog handles both. They just handle the loading of the data. They also don't support, like, obviously the pipeline framework in their structure, and then also the project template too. So you'd have to rely on other tools to get that.
So, last question was around here. Yeah, and I saw their hands rise. So, for you, I'm sure you can just approach Yatu and ask her personally.
Yeah, you guys can find me. I'm here.
Okay, again, thanks for the presentation. I think it's a really cool tool. It serves many purposes, right? I mean, it starts from templating and then defining the data catalog, releasing your model, etc. Now, in open source, there's many tools serving the same purpose. Like, for example, you could just use plain cookie cutter at the beginning, or you could use poetry for some parts of your workflow. Does it make sense to use your tool for only one particular purpose and use other tools for the rest, or is it all the way in or not at all?
You can choose. So the way that Kedro is actually structured is that you can choose to use like certain components of it. You're not basically restricted going project template in and then I have to like use everything. Some ways that the teams have used it, for instance, project template, they like the data abstraction, they're running a Kafka pipeline. and they basically make use of the functionality like that. So it's not necessarily like you have to like buy in completely. It's just you can use like certain components of it. And the libraries for the pipeline and the data catalog, at least the APIs are very stable. It's like they're very minimal changes between them. I'm trying to think of also another reason why you would choose to use it. Oh, this is actually related to how cool ways we've seen that people in the open source community use it. So we've historically used Kedro, obviously, to solve a machine learning use case. It was basically a business need, and you're basically solving, there will be an output, whether it's information's being pushed to a database or it's serving as some sort of front end. When it was released, we started seeing weird occurrences of people not solving use cases with it, but building what we call reusable pipelines. So basically making what we call doing 80% of their machine learning workflow, linking it to certain data sets that they would need as intermediate features, and then telling us that, hey, we keep rewriting this code over and over again because they're cookie cutter users, and now here's a way for us to actually structure that workflow. But whenever we approach a new data set that this needs to be used on, we obviously need to change the input somewhere. And Kedro basically has done 80% of the work because the code is there. We just need to make slight tweaks to make it work. So this whole thing of, I think we're finding interesting ways that it's been used where reusable pipelines, I think for one, has been quite interesting to see.
Thanks again. And yeah, let's thank Yetunde again.